Hello guys, so in the last two videos we understood how to configure static NAT, dynamic NAT and NAT overload, also known as PAT, port address translation. But that is traditional NAT. So we actually go from the inside network to outside, and the private IP addresses are translated to public IP addresses, and that helps us to hide our private networks and conserve public IP addresses. But now we are going deeper and understanding the actual concept of a NAT router or a NAT device. So how does a NAT device decide which part of the packet to be translated, source or destination? So how is it decided? And when we have the mappings of addresses in our router that this is mapped to this, how does router decide to translate from right to left direction or left to right direction? So you will understand this part a little better when I explain you with the example. But there are some certain decisions which NAT router has to make. So let's see what are some of the basic questions we have in mind about NAT, and let's answer them. And at the end of this video, you will have a lot better understanding of how netting works. So some general questions which comes into mind are these. How does NAT router decide which address to translate in the incoming packet, source or destination? Because every packet has two addresses, right? Source IP address and destination IP address. So we need to decide which IP we need to translate. And second thing, every IP address is actually mapped from A to B. There are two IP addresses. It can be a range or it can be a single IP to single IP depending on which kind of NAT you are using. But there is always two IP addresses involved. One that needs to be matched in the packet and one that will be the translated one. But the thing is, are we going to translate it in the direction of A to B or B to A? So how is that decided? And last question is that once the translation happens, then routing decision is taken, or is it taken before that? So when the packet comes in, does the router immediately checks routing table to find out the exit interface and then the translation happens, or does the translation happen first and then the routing decision is taken? So these are some of the core questions which if are answered, then netting will become very easy to understand. So to answer all these questions, let's go one by one. Let's go one by one. And the first part of this, we need to understand some basics of the net. For example, there are two sides, right? Inside and outside. And an interface can be configured as an inside interface or an outside interface. For example, if you see this diagram, we have a host which wants to access the Google server 8.8.8.8, and if you concentrate on the NAT router, we can see two interfaces, fast Ethernet 00 and serial 00, and we have designated fast Ethernet port as the inside and the serial port as the outside. So every port is a specific type, every interface has a specific NAT type, inside or outside. Apart from that, there are address mappings between addresses, and that can also be of two types, inside or outside. So if you see this configuration example, you can see that the interfaces are configured as the inside or outside, and then there is a mapping, IPNet inside source static, and this can also be an outside mapping, IPNet outside, right? So basically in this particular case, what we are going to do is we are going to understand how the NAT router decides to translate source or destination. So let me give you the rules now. So these are, I like to call them the NAT translation commandments, and these will tell you how actually the translation happens. So very important rules. So the first rule, if the interface NAT type inside or outside matches to the mapping NAT type, then the source IP address is translated, and that is also in the direction of A to B. Interface type, if it matches to the mapping type. What do I mean by that? So for example, we can see that the host is sending a packet to the Google server, and this is the part, the first packet upside here. So when this packet comes to the NAT router, it is arriving on the fast Ethernet 0/0 port, and fast Ethernet 0/0 port is inside port, and the mapping happens to be inside as well. So the port type and the mapping type both are inside. That means they are matching. And what happens when the interface type and the mapping type matches? The source IP address is translated. And in which direction? A to B, 10.0.0.1 to 201.0.0.1. That is exactly what's happening here. The source IP address 10.0.0.1 is getting translated to source 201.0.0.1, and then the packet is sent to Google server. At the return, when the Google server sends the packet back, source becomes Google and destination is 201.0.0.1, and this packet is coming on the outside port now, right? So now the net router says something is coming on the outside port and the mapping is inside. So now the port type where the packet is arriving and the mapping type do not match. And what happens when that happens? When the interface type and the mapping type do not match, the destination IP address is translated. But the catch is it's B to A. So the direction happens like this. The destination IP address, which is 200.0.0.1, will be translated from B to A. That is, it will be translated to 10.0.0.1, and the packet will go to the host router. So if you remember this rule, most of the netting concepts will be very clear. And the last part of this thing is that when does the routing happens? So this depends where the packet is coming. So if the packet arrives on an inside port, then the routing happens first and then the next translation happens. So first of all, you will check the destination IP address in the packet, find the check the routing table, find the exit interface, and then do the net translation. On the other hand, when the packet comes on the outside port, the net translations happen first. After translating the address, then you check the routing table to find out the exit interface. So with these rules, if you go through again with this diagram and these rules, you will understand how the net actually decides source or destination translation and the specific direction. No matter whether you're using static net, dynamic net, or PAT, that's how netting works. So I hope this video helped you understand how net works, and I would like to thank you for viewing this, and please comment and subscribe. Thank you very much.